welcome to the Journey Chez Chem. Well, today I have a big surprise for you. And I guess I'll tell you right now, we are not having the assessment today. We are having a pre-test, a pre-assessment. And therefore, the real assessment is tomorrow. But you need to pay particular attention to the warm-ups that we have today, and then we'll be able to get on with that practice for the assessment on 384. So go do the best you can, and we will talk about it in a moment. Number one is a review of how to rearrange the equations. And we are rearranging for both density and molecular weight. And I'm going to go ahead and do molecular weight first. Well, we know that the ideal gas law is PV equals nRT. And we know that moles are equal to grams over molecular weight. And therefore, I substitute it in. And then I rearrange it algebraically to solve so that molecular weight comes up to the top. Otherwise, if I leave it here, then I will be solving for the reciprocal, and I don't want that. So I'm going to multiply by molecular weight, and then that equals GRT. And then I want to isolate my unknown, and to undo multiplication, I'm going to divide. And therefore, molecular weight is equal to GRT over PV. That's molecular weight, which is the same as the AMUs, only when we're talking molecules, it would be a molecular weight. If we were talking about formulas, it'd be a formula weight. Now, in this equation, I also have the density equation. Grams over volume is equal to density. And therefore, I'm going to remove the other variables around it. And to undo division, I'm going to multiply. And to undo multiplication, I'm going to divide. And then I have grams over volume, which is density. And that's how you do number one. In number one, we are determining the ideal gas constant, R. And I know that oftentimes students just memorize the number. However, sometimes we sit in an assessment and suddenly we forget everything. So it's always good to know how to derive the ideal gas constant from the equation. And therefore, we have the ideal gas equation, and I'm going to be solving for R. And R is equal to PV over NT. Now, standard pressure in torr is 760 torr. And standard molar volume is 22.4 liters or decimeters cubed. And that is always 1 mole at STP, and that would be 273 Kelvin. And when I do the math here, I'm going to get 62.4 torr liters per mole Kelvin. Then, instead of torr, I also want it for ATM. And standard ATM is 1. And standard molar volume will stay the same. 22.4 liters is equal to 1 mole at standard temperature. And therefore, this number is 0.0821 atmospheres liters per mole Kelvin. And finally, for kPa, standard kPa is 101.3. 101.3 kPa. And standard molar volume is 22.4. But this time I'm going to use decimeters cubed because liters are equal to decimeters cubed. 22.4 decimeters cubed is equal to 1 mole at 273 Kelvin. And we've done this before, and this should be review for you. And my number here is 8.31 kPa decimeters cubed per mole Kelvin. And that's how you do number two. Now, I know you must be pretty relieved that today is not the assessment. And, however, you do get to practice some more problems, and therefore I would expect that you'll do exceptionally well tomorrow. So you do the best you can, and I can't wait to see you tomorrow.